from we have Scott Holek, okay, from PDC, Pat Brandon from Design Alaska, and Alex from Gulfstream Engineering. I don't know your last name either. All right, so we'll go ahead and get going. You're up, Jules.
Yeah. So if I can take part of your attention away from your pizza for a couple minutes, I'm going to present my design for ice arch this year.
Julia, please speak up.
So I'll start with just describing the site plan that I had chosen. There were a couple other spots near the library, but I thought, you know, like the last couple of years, it's always been in that spot, and it's just because it's just a really great spot. It has power, and you can view it, you know, the circle goes all the way around. And I chose it to kind of face the way that it's shown. Just so that, because I was thinking, usually when I like move through this spot right here, I usually start like, you know, over there, and I come straight over here, and I go around the circle. So I just thought if it's facing this way, you know, you kind of see it from the side, and then you walk around, you view the front of it, or view the back of it. So I just, you know, decided that was best. So during construction, I was thinking we'd put safety fences around the inside of that circle. So like the inside of where the beds are for the plants. And then after construction is done, then replace it with like some nice rope and like a sign, you know, that describes what it is. So the shape of the arch is going to be a catenary curve. And I thought for those of you who aren't familiar with catenary curves, I'd describe it a little bit. So an arch is a catenary curve, but it's an upside down catenary curve. So if you think about the shape of a catenary is made when like a rope, or like if you think about a chain, like the links of a chain, when it's just pulled down by gravity. So, and that shape is formed when the force of gravity pushing down on it and the forces of tension where it's held at each end cancel out to zero. So the tension in the chain goes through the center line, and if you flip that upside down for an arch, then instead of tension, you have compression, and the compression goes through the center line, and then it goes straight to the ground, which is good because ice doesn't do well under tension. So the point of that's why it's ideal catenary curve for an arch, and especially an ice arch, because it takes away the tension, which can cause like it to buckle or bend. So there's the arch that I designed. There's two things. So first, it's going to have it's going to spiral. So going from the bottom to like halfway, it'll turn 90 degrees. And the blocks that I chose to do the blocks, the cross section to be 8 inches by 14 inches, so that if you pretend these are the blocks, as it goes up, they'll turn, and so it'll look like at the bottom the ice blocks are smaller and the ones at the top are larger, but in reality the cross section is the same throughout, which is important because a catenary curve arch, one of the requirements, it needs to be a uniform cross section in density. So that was kind of the idea behind it, was that it'll turn, it'll twist, which will be cool, and then also it'll look, from the front, it'll look like the bottoms are smaller, the top is larger, and then from the side, it'll look like the bottom's larger and the top is smaller. Oh, and the ice block figured out to be about 37 pounds, which is pretty reasonable to move around and shape. So for the lighting, I didn't want to get anything too fancy because the arch already has a lot going on. So I was just going to do like a rope light that starts from one end and it follows the curve to the other end. And then also do like 2 floodlights, so one on one end and one on the other, just to kind of, you know, spotlight. So here is, it's from Excel. So there's the Catenary Curve, and it's going to be 15 feet tall. So that's the shape of it. And so the forces, really the only forces that are good to know in this arch will be the shear force or the shear stress at the where the arch hits the ground. And I figured that out to be about 7.18 psi, which is not very high. So yeah, it shows the ice block just 37 pounds, and the complete arch will be about 1,600 pounds. So if you think about how you create a falsework for this arch, usually you think about like a plywood that's like bent to the shape of the arch, but obviously that wouldn't work, you know, because it has a twist in it. So my design advisor, he suggested an idea to me that was used a while back, and this is actually the falsework that he used. That's similar to the one that just similar to the one that I'm going to use. I'll show you. So it'll be like plywood up on the edge, and it'll have notches in it, and the wood that goes in those notches will be shaped to each block so that it will support the twist. And you can, when we're cutting these, we can cut them to the right angle that it needs to be. So each block will have one of those notches that will support it all the way up. And then the scaffolding will just be, we'll just have to use normal scaffolding to do the top blocks. So for the material list, just a couple of things. The ice in the last arch that used stacked blocks was in 2016, and they got their ice from Ice Alaska, and they had them cut the ice also and transport it here, which is probably the better idea than having students with chainsaws. So yeah, just some equipment that we probably use, and then I mentioned there's power in the flag circle. And there's some safety equipment to use. So yeah, I used in 2016 when I got the ice blocks from Ice Alaska. They're nonprofit, but to take all the ice and to also have them cut the ice, that year they gave them about $400. So I figured, you know, that was probably. Questions?
So I was curious, how do you intend to bond the blocks together for that shear force?
Just with some water.
Water.
yeah, as you stack them, just water.
Is that how, so, because you've got cubes, right, and they're not tapered, right? They're just cubes. So how do you, when you make an arch that, you know, the outside corner's gonna splay out? Are you intending on tapering the cubes, or?
Yeah, so each block, as we build it, will be taking off, you know, parts of the ice so they will, yeah, they'll be probably like, they'll create that angle.
My question was kind of along what he was thinking too. Will each block be uniformly shaped, or will you be kind of shaving it off as you're building it?
We'll be shaving them as we go. So it's important, you know, for it to be structurally sound at the end, you know, for there to be good contact between each block. So that's pretty much most of the time in constructing it is making sure that, so you'll probably, you know, you'll shape it and you put it on and then you'll take it off and you'll shape it again, you know, to just make it right. And that's the importance of having the blocks under 50 pounds so that you can kind of take it on and off without too much effort. Do you have a question? Yeah.
So on the bottom, very bottom blocks where they connect to the concrete or snow or whatever you have on the bottom there, what's keeping them from kicking out? Just weight or?
Just there's not a whole lot of force. There's not a whole lot of shear stress in that spot. Like I calculated the horizontal force, it wasn't very high. So I don't expect, you know, and at the end, it's going to be supported until the end. And then at the end, all of these blocks are pretty much fused together. So it kicking out at the end is it's not going to be an issue.
Okay, so you're relying on bonding between the blocks to kind of prevent the
Yeah, and once they're done, they'll settle in and they'll be in compression. So that
And then just one other question, the $400 per block, is that including delivery up here, or is that just for them to make it and cut it?
including delivery. And it's not per block, it's for the
Oh, that's right.
that would be pretty there's gonna be about 43 blocks.
So how much rotation have you figured out between each block, one to the next, degree of rotation? So from one to the next, obviously you're turning as you're going up, but how much of a turn?
I haven't figured that out, but it's 15 feet high, and there's going to be, if there's 43 blocks total, there's going to be about like 21 blocks on one side. And just from here, I'll go back to the picture. There's not going to be a whole lot of rotation between each block.
And so when you're doing your calculations on the Catenary Curve, did you take into account the surface area between the blocks that is reduced because of not?
I didn't, but I think because they're all in the same center line, I don't think that should have much of an impact. You know, the little bit that they're not touching. Did I answer your question?
Yeah.
Any other questions?
So how do you intend on, so it's going to be kind of complicated for the formwork, right, to get that 90-degree turn on both sides. How do you plan on cutting out making that formwork for each plywood?
False work, you mean the piece of wood that's going to be in each notch?
Right, yeah.
Well, first I'll figure out the angle that they each need to be turned at. And I think, you know, part of the design of the false work that I had, it's pretty easy to take apart and modify. So I think coming up with, you know, obviously I know how many blocks there's going to be, and I know the spacing. So, and I will figure out the angle between, you know, each turn. Probably come up with them, come up with how much needs to be cut, and then once I'm done, as we're stacking the blocks, if one needs to be adjusted, then just do that as we're going along. It's not very hard. Do you have anything else to ask about, the false work?
No, I think it's a really cool design. I think it's going to be a little tricky to custom shape those blocks because you're going to have to shape two planes as it rotates.
Yeah.
But I think out there, that's just something you do by feel when you're laying the blocks.
Yeah. And the normal method for the stacked blocks is to shape each block as you go along. And obviously the false work is going to be supported, by 2x4s. So it's not just plywood on the edge.
Small piece of input. There is a way of shaping two blocks at the same time. So, for example, let's say this is the top face of one block, and this is the bottom face of the next one. And both of those are cubic, so they don't fit. You use a thicker curved tool, a thick curved saw, and cut them both at the same time. And what happens is it makes a matching set of faces between the two blocks. I've done that with timber, with chainsaws, very easily.
Keep that in mind.
Anything else? You can give me to Multi actually.
All right. Hi guys, my name is Wenshi Fraser. I am a senior civil at UAF. I would first like to thank ASE and AGC for putting this competition on. It's a great opportunity for students. And I would also like to thank Wilhelm for helping me come up with a constructible design. And lastly, I would like to thank judges for taking time out of their day. So to start with, this is my ice arch. How do I click? Here it is. I drew it up in AutoCAD 3D. For life of me, I couldn't get dimensions on there. So this is what you see, and I'll be showing this slide multiple times throughout. So this arch is a 2-arch system. They are identical to each other. There's a 2-foot gap between them, and the arch is 14 foot tall with a 13-foot clearance. And this is made of block ice. And these arches, there's a small detail right here where they are connected with ice. And I will show you more about that later. And these white pieces are rebar, just not for structural, just for this blue line, which is for lights to be put in between the two arches so they illuminate both arches. Okay, so for the blocks, I chose a 1 foot by 1 foot by 1 foot normal blocks for the majority of the arch. These blocks do weigh about 57 pounds, which is pretty hefty, but doable for building. And for 2 arches, this would take 60 pieces based on the height of my arch. And then this detail piece is would span between the 2 arches, and these bases would sit on the arch, overall arch. And this is actually 4 inches. Ideally, you would cut out with a jigsaw these little sections to lighten the load, because this overall piece does weigh 76 pounds and would take about 2 people to set on the arch. And so going back to this, as you can see, so these are where the detail pieces are. I connect them on both sides. I chose 4, 2 on each side on the bottom. It would get more difficult to put these here at the top because of building and keeping things aligned. So generally, you should be able to start out with a pretty good base. And for the rebar, this is, again, as I said before, does span between the 2 arches. So I would say they should be about 2.5 foot long. This gives you 3 inches in ice on each side. And for them to be every 2 feet to make sure the lights don't sag throughout the arch, I'd say space them every 2 feet, and this would require about 12 pieces of rebar. I say just paint them white so they don't just stick out all steel colored, more blended with the background because they aren't the main look of the arch. And then for placing the rebar, center them in the middle of the block guys so the lights aren't too high or too low. They evenly split the light. And then in my drawing, I do have them wedged between every 2 blocks, but this gets tricky when you're building and you have to have them at the same pace, and then the rebar would look a little crooked. So ideally, I would maybe suggest just starting out by drilling holes on each side in each ice, and then sandwich them together as you build up. And then for the lights, as I say, they would be put on top of the rebar and then attached with some wire. And ideally, I thought blue LED, because of our school colors, would look pretty cool. And maybe you could get lights that change colors, whatever your mood is. And then for the bottom, where the pieces of ice span between the 2 arches, I thought maybe not as stable because that's too small, but something like that to attach the lights to the ice so they don't just fall all of a sudden, they still follow the curve of the arch. So again, we look at the arch, and so the rebar, as I said, these right now show them between the 2 blocks, and they would have to be altered slightly to make sure they don't make the blocks rock back and forth, but also you could just drill between the blocks and put them between there. And then the lights here, they would just be attached on the back side of this. So for load calculations, I did also follow the catenary arch, just a simple, quick way to make sure that the arch will hold its self-weight. And so following this equation, which does give you a sag curve, I inverted to make the arch shape, put this in Excel to plot the points that I needed, and then put those points into CAD to get a appropriate points and appropriate drawing of what it should look like. And then, so once again, you see the photo. And then, so for site plan, I also chose the Cornerstone Plaza. This is just an easy place to build and keep your site central, and you can keep your things in one place. And it's close to Eli. I did situate the arch this way, so as you exit Eli, you can see it right there, and then you can walk around it. And then this yellow is where you would walk it off for, so the pedestrians don't walk through, and ideally just caution tape or some kind of warning. So keep the site safe. For the build plan, this was previous years. Again, do some kind of wood frame in the shape of the 13-foot clearance. And then ideally it would span 4 feet because they are identical arches. You could build both arches on one frame. And then, so then you would start out at the bottom and build your way up towards the center, and you'd want to keep the same pace with the 2 arches because of the rebar that you would have to place. And then as you get near the top, you would want to set some scaffolding so you could reach the top parts. And then so same thing, but you would fit the whole framing under all of this to get both of them. There's not quite enough space to make 2 different supports, so just one big one. And so for the cost, I tried to contact Ice Alaska, but they weren't able to give me a quote by the time this presentation was. That was to be determined, but based on Jules prices, it will be pretty costly because it's a lot of ice, but I think it's the best way to go versus taking your own blocks. And then plywood and screws for the structure, get it at Home Depot. Should be relatively cheap because this is just a temporary frame. And then the rebar for the design, and the wire, and the spray paint, and the blue lights. And then already contracted out is the design and construction costs. And for the schedule, I did list out just some basic, easy tasks needed. So very simple. Ideally, the build team would have a longer list with more details. But frame the structure, contact Ice Alaska, gather materials, cut the wood and rebar, build the wood frame, obtain the ice blocks, and build the arches, and then put the lights on, remove the wood frame, and you're pretty much done. And on this side, I put estimated amount of hours. This is a rough guess. And then on the right, in the parentheses, how many people would be working on it, because hopefully it'd be a multiple people, FT build team, and a lot of help. And so I also laid this out in Microsoft Project, which will be on the next slide. But before I show you that, it's easiest to tell you my parameters for the schedule. So ideally it would start beginning of December, sooner the better, and just so you can enjoy the ice arch longer. And then you'll see this on the next slide, but I decided for the build team, work Monday, Wednesday, Friday, 3 hours a day. So it's quite a bit for the beginning. Ideally it'd be just a little bit at the beginning and a lot more hours at the end, but this was easiest to schedule out my plan. And then ideally, if anyone stays in Fairbanks for winter break, maybe work through winter break so you can get even just the framing done, so you can start the ice arch right in January. And then I did have take the holidays off. And as for the biggest thing is ice arch, so estimating the time it would take for that to be made is challenging. Those ice blocks are, you have to, it's 1 block at a time. They're not all going to be identical, so it's going to take a while. I know Wilhelm estimated that if you take about an hour a block, I was hoping that maybe with lots of help, this could be cut down by 30 minutes, but it just varies. And then I know last year's deadline was to finish by E-week, so that's where I set it. And so you see the schedule. It does skip the weekends already, and then the gray is the holidays. So you start in December. This shows it ending right at the beginning of February. So ideally that would be great, but also this time could also be expanded longer, depending on how long it takes to take that search. So, any questions? Yes.
Using the software, would you be able to actually model block by block what the angle is that has to be cut on them, so that some of that prep work could be done before they're actually working in the air and scaffolding?
Yeah, I mean, when I drew out this, I had one block and set the corners on the pivot so they would match up. So you can see there are gaps here, so this would be the general angle. The shape would just have to change a little bit, so yeah, you can do that.
I mean, that's your intention, is to taper the blocks the same way?
Yeah, one by, they're not gonna fit exactly to the arch, so you have to make sure there's not giant gaps.
So you would start with a uniform cube for each one and cut them.
Yeah.
You put any thought into interface between the blocks, like how you're gonna bond them?
Also water, once you get enough contact surface area that you find, then the water and how that.
You wet it and then set the block on it?
I know before they use like the eye droplet thing, so you can get the water around it and use it too.
Have block ice arches ever been built or like at least sized out horizontally on the ground first, and then their angles cut in place, and then stacked vertically on your primary forms? Or is the history of block arches typically cut in the vertical or take measurements, get close, and then finalize on the vertical?
Yeah, I think it's been one by one, not laid out on the ground. Just because. Yeah, you can try that. Yeah.
What's the purpose of those links down at the bottom?
Just some interesting detail. Yeah, so if that poses to be too difficult, you could just replace them as blocks and just add 2 arches.
So on your tools, you list the scaffolding. Have you actually talked to anybody about doing scaffolding?
I have not, but ideally, we are being funded by ASC, AGC, so I would guess people would offer donating that scaffolding because they're not doing much construction at this time. But I have not contacted anyone.
Okay.
What else?
How effective is snow fencing and rope keeping people away from the ice? Because I'm looking at this and I see a jungle gym.
Yeah. Yeah. I don't know. I would hope that people wouldn't walk all over it. Ideally, I mean, the caution tape that's been used before, it's not too pretty, but it does lure people away from walking through. Hopefully that would really.
To account for the gaps between, do you have any plans on getting the blocks delivered a little bit oversized?
Yeah, ideally that would be the idea, so it would fit. And so you're not getting a smaller arch than you planned.
Is all this formwork being constructed outside? Can you assemble it in Duckery somewhere?
Yeah, I was thinking pieces cut in the shop, and then it has to fit in the door. So maybe whatever you can build inside, and then ideally after that end, put it all together.
I think the schedule is great. You put a lot of thought for the schedule. That's good. I know when I was building the arch here, I did not think about schedule. Totally. It always takes longer than you think. You end up doing it later. That's good.
You're quite the optimist. I think there's something behind it.
Yes, yeah, I was afraid people from the build team interested. I didn't want to dissuade them from being part of this project if it was too long. So that was optimistic. Yeah. Mark?
Do you have any concern for the 2 arches acting either differently or maybe the rebar actually hampering it, where say you have a wind load on one, but it's being sheltered by the other? Anything with regard to that?
No, I didn't think about too much about that. I'm hoping that the rebar isn't gonna transfer any forces between the two arches too much. It's not structural, as I say, just something to hold the lights. So ideally, they should hold themselves, the two arches. So then I can find. Any other questions? All right.
Alright, well, thank you, Jules and Wenshi. We're gonna have the judges go into the conference room and discuss, who they think should be the winner. So while they do that, we'll be in here and we'll kind of just go over some upcoming club stuff for you guys. So just give us a moment to sign. Kind of bummed that we can only build one. But would like to say congratulations to Juliana. Right, we won't do that. All right, so we will be making the twisted design this year. So and thank you for all the time that you put in, Wenshi.
Okay, so construction
Begins now.
begins now.
Yes, so if anybody's interested in being the build captain, I will get that addendum added onto the rules that adds the $100 in for the build captain. That is still underway. But please start getting with Juliana and Wilhelm on creating the build package.
So when are we going to announce the, when are we finalizing the build package? decision?